Hey guys, welcome back to the session. I'm Divya, fourth sem EC student. In this session, we are going to learn about the subject of circuits and controls. In this subject, we are going to discuss about the problems on superposition theorem and Thevenin's theorem. Before going to the problems, we'll discuss about the statement of superposition theorem and Thevenin's theorem. Let's discuss the statement of Thevenin's theorem. Thevenin's theorem states that any linear circuit containing several voltages and resistance can be replaced by just a single voltage in series with a single resistor. Now let's discuss about the problem based on the Thevenin's theorem. The Wheatstone bridge in the circuit shown in figure is balanced when R2 is equal to 1200 ohm. If the galvanometer has a resistance of 30 ohm, how much current will be deducted by it when the bridge is unbalanced by setting R2 is equal to 1204 ohm? So this will be the circuit and they are given the 120 volt of voltage and R1 will be 900 ohm, R2 is equal to 1200 ohm and R3 is equals to 600 ohm and R4 is equals to 800 ohm. So they are given the galvanometer of resistance 30 ohm. So we need to deduct a or we need to find out a current here by changing or by unbalancing the R2 resistance of 1200 to 1204 ohm. So let's going to discuss about the solution. To find VOC, we are interested in the galvanometer current, hence it is removed from the circuit to find VOC and we get the circuit as shown in below figure. In this figure, we are removing the galvanometer here to find out the VT or VOC of the circuit and we are replacing the 1200 ohm of R2 resistor as a 1204 ohm resistance and we are applying the KCL here to find I1 and I2. By applying KCL, I1 is equals to 120 volt divided by 900 ohm plus 600 ohm, that is equals to 120 divided by 1500 ampere. And to find the I2, that I2 is equals to 120 divided by 1204 ohm plus 800 ohm, that is equals to 120 divided by 2004 ampere. Applying KVL clockwise along the path in this loop, 1204 ohm B minus A 900 ohm, we get 1204 ohm into I2 minus VT minus 900 into I1, that is equals to 0. We need to find out VT here. VT is equals to 1204 into I2 minus 900 into I1, that is equals to 1204 into I2 is nothing but 120 divided by 2004 minus 900 into 120 divided by 1500, then Vt is equals to 95.8 microvolt. We need to find Rt, deactivate all the independent sources and look into the terminals A minus B to determine the Thevenin's resistance as shown in the below figure. In the above equation, we found the total voltage of the circuit. Here we need to find total resistance of the circuit. So we are removing the all independent sources here and we can modify the circuit as in the given figure. Then RT is equals to RAB. RAB is equals to R1 into R2 divided by R1 plus R2. So R1 is equals to 600 ohm, that is parallel to 900 ohm plus 800 ohm is parallel to 1204 ohm. So we need to find 600 parallel to 900 here, that is equals to 900 into 600 divided by 600 plus 900 is 1500 plus 800 is parallel to 1204 ohm, that is equals to 1204 into 800 divided by 800 plus 1204, that is equals to 2004 ohm. Then the final value of RT is equals to 840.64 ohm. So finally we got the total voltage and total resistance of the circuit. Total voltage is 95.8 microvolt. Total resistance is 840.64 ohm. And by including the 30 ohm of the galvanometer resistance, we need to find the current passed through the galvanometer here with the region of A and B. Then Ig is equals to VTH divided by RTH plus RI. Ig is equals to 95.8 into 10 to the power of minus 3 divided by 840.64 plus 30 ohm. Then we finally got the Ig value, which is the current passed through the galvanometer, that is equals to 110.03 microampere. Now let's go to the superposition theorem. Superposition theorem states that the current through or voltage across an element in a linear bilateral network equals to the algebraic sum of the currents or voltages produced independently by each source. Now let's discuss about the problem based on the superposition theorem. For the circuit shown in the figure, apply superposition theorem and find the current I. So this will be a circuit. We need to find out the current I in this circuit. We are modifying the given circuit by opening 5 ampere of current. The resulting circuit has shown in the below figure. We need to find out Ia here. So to find Ia, we need to find impedance. The impedance as seen from the voltage source is Z is equals to 4 minus J2 plus 8 plus J10 into minus J2 divided by 8 plus J8, that is equals to 6.01 angle of 45 degree ohm, and Ia is equals to J20 divided by impedance. Impedance is nothing but 6.01 angle of 45 degree ohm. Then Ia is equals to 3.328 angle of 135 degree ampere. Hence, next short the voltage source and retain the current source. The resulting network is as shown in the below figure. So this will be the circuit. In here we need to find out the IB current here. So we are making I3 has 5 ampere of current. By applying KVL to mesh 1 and mesh 2, this will be the mesh 1 and this will be the mesh 2, we get. By applying KVL to mesh 1, 8 ohm into I1 plus I1 minus 5 into J10 plus I1 minus I2 into minus J2, that is equals to 0. And applying KVL to mesh 2, I2 minus I1 into minus J2 plus I2 minus 5 into minus J2 plus 4 into I2, that is equals to 0. Simplifying equation 1 and 2, we get 8 plus J8 into I1 plus I2 into J2, that is equals to J50. J2 I1 plus 4 minus J4 into I2, that is equals to J10. And by solving the two equations, we get IB is nothing but I2, that is equals 8 plus J8 J50 divided by 8 plus J8 J2 mod of J2 minus J10 divided by J2 4 minus J4. By that we get IB is equals to 2.897 angle of minus 23.96 degree of ampere. Since IA and IB are following in opposite directions, so we get I is equals to IA minus IB. By subtracting the IA minus IB, we get 6.1121 angle of 144.78 degree. Thanks for watching.